All right, chapter 8. So we've created all these great websites. Now, where are we going to put all this stuff? And that's the whole point of chapter 8. We're going to be looking at the hardware and software and the utilities that can be used to manage our website. So where are we sticking it, right? So let's go over a quick review and kind of put it in context, chapter 8. So if you remember the things we've talked about, the internet foundation, the history, the architecture, we looked at different revenue sources, web presence, advanced technologies such as social media and mobile and auctions. And then we also looked at different marketing and B2B that builds on top of all that. So what's next? Well, there's actually something that goes in between here that we have not talked about. I take that back. We've talked about some of it, how to build a website, and we've talked about HTML. I've introduced you to JavaScript and CSS, even though we didn't cover it in detail. But there's one more piece in here that we need, and that is where do we put the website, and that is in a web server. So the whole point of chapter 8 is talking about this. Where do we stick this stuff to get to work? So it's a little bit more technical, some of the stuff we're going to talk about and understanding. But I want to try to approach this more as not just what are the bunch of names of servers and operating systems, although those are important. I also want you to be able to start thinking through, okay, once we know what these names are and can compare them, what are the best solutions for a business? So you have to understand the different ones in order to make good decisions. So let's find out what's out there. And we're going to start on the hardware side and then build more towards the software, and then lastly look briefly at utilities. I'm not going to spend a lot of time on the utilities, but there are a number of different pieces of software out there that can help you with that. But okay, so starting with the hardware. And here's an important thing to realize is that web servers can range greatly in price, from as cheap as $800. In fact, you could probably take your home computer, even a laptop, and turn it into a web server if you wanted to. It could be even cheaper than that. I could probably take a $200 computer and turn it into a web server. It's not going to be very good. It won't be able to handle much bandwidth, but you could do it. And if you have a really small site that you expect to only be used for maybe 10 of your friends, that's not a big deal. However, any business that wants to create or have a website is going to want something that can handle a sufficient amount of bandwidth and a sufficient amount of traffic. And so really getting under that $800 mark is just not feasible. And even that is a very baseline, and you'd probably want to strip out 90% of the programs that come with the server, because you want to dedicate it just towards serving websites, and anything else you put onto it is going to slow it down. As you get into far more advanced and far more high throughput websites that get maybe 1 million visitors every day, or even once a month, 1 million visitors, you're going to need something much more powerful. You go to a company like Google or Yahoo or Amazon or Facebook, and you'll see that they need many, many very expensive servers to handle the traffic they get every day. Now, some websites have even gone as far as buying a small mainframe, and that can be around $200,000 up to $500,000. And they do that because of the reliability that mainframes have built into them. Now, you have to also realize there's a lot of different types of servers that you can purchase. Some servers are optimized for web traffic. And if you ever do shopping for a web server, that's one thing you're going to have to look for is not only, yes, we have lots of different types of servers that are really good at serving information up. Some of them have been designed to be optimized for web traffic. Okay, that's probably where you want to focus your efforts. Now, some important concepts. If you're ever trying to create a hardware-software combination that is perfect for your business, 3 big things you need to keep in mind. One is the concept of benchmarking. So a benchmark is essentially a standard or a way of figuring out just how fast something is. So you might say, well, I want a website that can handle 1,000 users accessing this page every second. Okay. How long does it take this particular software-hardware combination to deliver 1,000 requests? And so that's how you'd get into like benchmarking. It's looking at how many requests can be returned within a specific amount of time. So it deals with not only the bandwidth coming in, so it's got to be able to have the throughput to take all that, and well, that's throughput's the next one. Then it has to process it and do something with it, and then send it back. And that whole process, though, is that there's a time that goes into it. So when you're looking at benchmarking, two big measures that you look at is throughput, in other words, how many people can request at the same time, and response time. And response time is sometimes based upon throughput, but not always. So I could have a hardware-software combination. Like if I bought an $800 server, it might be able to handle a high throughput. You know, it might be able to take 1,000 users, but response time is going to be much slower than a $200,000 server, even if they could both handle the same number of people. Okay. Likewise, the response time could be much quicker if you have the right bandwidth to get there, but the response time. Sorry, I'm confusing myself. God, I hate when that happens. So the throughput. So it's a way of kind of looking at, as an analogy, think of a pipe with water running through it. Okay, the throughput would be how big a pipe is it. The response time would be how fast the water is actually going through it. Okay, and between the two of those, you have a certain amount of pressure that gets built up within the pipe. So it might be, you know, how much pressure it can take, and depending on the throughput and response time would be how much information you can dish out. So a big pipe can take lots and lots of information, but if it's a bunch of slow-moving water going through it, you're not still going to be able to handle a whole lot. Okay. Likewise, you could have a very small pipe, but it's being shot through at a very high pressure and going through it. But once you get to a certain too high a pressure, the pipe breaks, right? So there's a limit to how fast information can go through it. So that, and benchmarking is trying to figure that out, okay, based upon different hardware and software combinations. So the hardware, the actual server, and then the operating system that's being used, and various other software, pieces of software that are on that piece of hardware as well. All right, so other important concepts to understand when you're thinking about hardware would be its overall architecture. The main difference you're going to look at, for hardware at least, is it's centralized versus distributed. So what do I mean by that? Well, you can have basically a singular, one piece of hardware, centralized, or a distributed architecture where you have multiple different pieces of hardware all working together to handle the load of the processing. Okay? And that's where this concept of a server farm comes from. It is a type of distributed environment. Now, when I say distributed, it may not necessarily be that each server is doing the same work. Some of them could be doing different work. In a server farm, all of the servers are doing the same job, but they split up the job so that each one's taking a different number of requests. So you might have, let's say, 10 servers that are all handling website requests. The same website is on all 10 servers. As new requests come in to a router, the router splits it up into 10 different equal categories for each of the 10 servers. And each server does its processing and sends the information back through the router, and the router sends it back to the people that requested. So that's essentially how a server farm would work. In an architecture that's distributed, yes, that could be a server farm, or it could be that you have a website, you have a database, you have an email server, and they're all on different computers or distributed. And that's how you distribute the information. So each one, you have to kind of tease out the differences and distribute it there. Now, we're even seeing today where you have this concept of a virtual server. And we'll talk more about this a little bit later in the class, in this lecture here. But this virtual server is basically saying, when I say that, I'm referring to the web server has been virtualized so that we don't know what piece of hardware we're working on, nor do we really care. We're working directly with a certain operating system, and we know how to access that operating system, but we don't know on what piece of hardware it's on. Okay, and that piece of hardware may end up having multiple different servers, operating systems, or instances of the same operating system on it. Okay, that's called a virtual server, and so that's when the hardware basically becomes unimportant from the web developer's point of view. Now, from a systems admin, they're still worried about the actual hardware itself, okay? But as a web developer, you're not. All right, so what are some of the different server software? We talked briefly about that we have to have something. Well, the first, obviously, is your operating system. You got to be able to do something to make the hardware work, and that's what the operating system does, right? And you also need a web server, okay? So the operating system basically manages the hardware, so the memory, the inputs and outputs, and communications, and all of that. A web server has one job only, which is to serve web pages based on requests. So as HTTP requests come in to that particular server, it recognizes them, searches through its, all the web pages you have, finds the appropriate one, and sends it back out. The two most used are called Apache and Microsoft IIS, stands for Internet Information Systems Server. Internet Information Server. Apache is by far the biggest. It is an open source, so which means it's free. Microsoft IIS comes installed by default on almost all of their web server, all of their operating system servers. So Windows Server, what's the release version? 2008, I want to say. Windows Server 2008 has IIS as an add-in that you can install or not install. Okay. So essentially, if you have a Microsoft computer, it is free, but you've already paid for the operating system. And Apache is free as well. Both of them are very high quality. You'll find people out there who will prefer one or the other. Actually, at this point, I think they're very comparable in quality. There's, I'm sure, some differences at the high end, what each one can do. And I haven't worked in the high end, like at a Yahoo or a Google, to give you the best rundown of those. Strictly speaking, though, and I shouldn't say strictly speaking, but in general speaking, both of them will get the job done for most businesses out there. And so I wouldn't even recommend one over the other. I'd say they're both high quality. And there are a few other web servers out there. I believe there's a Java version. I can't remember the name off the top of my head. But I believe it's 80 to 90% of all web servers are on Apache or IIS. And so those are the only two that I'm really even going to worry about. Then you can also have email servers. As you might imagine, serves email to the appropriate addresses. You can have those. Now, it's also possible to use a system like Google Apps, which can handle your email. And you run it basically through Google Apps, and it does the email server for you. So you don't have to put that on your own hardware. They do it. Okay. All right, so let's talk a little bit more about web servers. What do they do? Well, software sometimes executes web page code before serving a page to a requesting computer. What do I mean by that? Well, we've already worked a lot with HTML, JavaScript, and CSS. And you probably know that each one of those, especially like JavaScript, it does stuff, right? It creates behaviors that a web page can do, but it does it on the client machine. There is a way to do some processing, some behaviors, or some control of the pages on the server before it's sent to the client. Okay, and this is the primary difference between a static page versus a dynamic page. A dynamic page is one that can be changed right there on the server before it is delivered to the client. And I bring this up because this is what we're going to shift focus the rest of the semester on our web development into understanding one particular server-side scripting or server-side programming language called PHP. Now there's a lot of other good ones out there, web programming languages like ASP.NET, there's Java and Java Server Pages, Cold Fusion, Perl, Ruby, Ruby on Rails, Python, just to name a few. Okay, PHP is probably the most popular at this point, and so that's why I'm going to teach that one to you. ASP.NET, and so if you guys have had Visual Basic, Basic.NET, and along with Visual Studio, it's very easy to use ASP.NET within that framework. So don't be afraid to play around and learn that as well. Okay, so why would you want to use server-side scripting? Well, there's several cases where you're going to, and the big one is more for security. You want to have the code that you're doing, you want to not display or not let any of your users see the code to. With JavaScript, you're actually sending the actual JavaScript file to the client. So the user, if they wanted to, could read that JavaScript file and see whatever code you've put into it. Now that can be very dangerous if you want to access some database information and display that data for the user. Okay, because now if they have access to your database, all it takes is one nefarious, or ticked off user. They could easily hack your database and either delete all your files, or there's cases where they could read everything in the database, even stuff you're trying to hide, or start adding data to the database, so much data that eventually they overwhelm the database and it basically breaks. So there's a lot of cases where you want that safety where they can't see the code. And then there's other cases where you don't want to put all the processing on the client machines because that would bog down their machines by doing all this stuff. And it'd be more efficient to do it on the server. Okay? So yeah, you'd create your own server-side scripts to do those types of things. So I would say those are probably the two biggest reasons why you might want to focus on PHP or to do server-side scripting. All right, moving on. Other server stuff includes the database. All right, so we talked about, that's what's great with PHP, ASP.NET, and Java, Java Server Pages, is it gives you that ability to access data and display it. Now this, probably more than anything else, is the reason why web pages have become so extremely popular. It's because it gives us the ability to access data, to store information, and retrieve that information and present it back to users. So the success of Web 2.0, remember that? The only reason why that can work is because we have a database server that can serve up data, that the web server can access the data in the server. You can program it using server-side programming, display that information, add new information to the database, even delete information in the database, and have complete control over it. So the database, while it can be on the same server as the website, most big websites often separate these two into two dedicated computers. You gotta have some server-side programming to connect to the database. Could it be done in other ways? Yes, there actually is a way to use JavaScript to communicate with the database. It's very dangerous, though, to do so, like I mentioned. And what a lot of people do is there's a number of things. I'm not going to get into the details of it, but there is a way of using JavaScript to create an XML file, send it to your PHP page or your ASP.NET page, which then sends it onto the database. The database returns, yada, yada, yada. So you can do some ways of protecting data as it's delivered to and from JavaScript, but I don't recommend it. All right. Usually you set up a separate database instance for end user for each website. So as you might imagine, the database server, so like Oracle, is really more of a database server, which has many databases in it. And each database might have multiple tables. Each table has multiple rows and multiple records. Generally what happens is for one website, you'll have one database, so an instance of the database and a user to access that database. And then very rarely will you have a user that can access two data. And sometimes you'll have a user that can access two databases, but it's pretty rare. That's generally the breakdown. Okay. Common database servers include, like I said, Oracle, MySQL, SQL Server, and they're the ones that help manage creating the databases and running them. All right, server architecture. So you may have heard a little bit about this before, like the difference between a 2-tier and a 3-tier architecture. Well, the web, as you probably heard from my language that I've been using so far, does use a client-server based platform. Now, usually it's more of what might be called a thin client, meaning that very little work is done on the client. Most of the processing is done on the server. Got that? So a thin client is most work is done on the server versus what its alternative is called a thick client. As an example that's not a thin client might be my Microsoft Outlook program that connects to the Exchange server here on campus. Okay, the Microsoft Exchange server is their email server. It does a lot of processing of the emails and sends it to my Microsoft Outlook program. My Microsoft Outlook program then does additional processing, but it's pretty thick. It does a fair amount. If you looked at all the processing that Microsoft Outlook does, such things such as spell check, it allows you to move very easily email to different folders, and displays a lot of information. So it does quite a bit of work. Okay. In the web arena, we don't assume that. A browser is not designed to handle very heavy processing. It does just a little bit, the HTML, CSS, and a little bit of JavaScript. And you usually don't want to overburden a browser because they're not designed to handle lots of heavy stuff. Okay. So the web server to the browser is considered a 2-tier architecture because there's two, right? You get the server and the client, and that's it. So what would you think would be a 3-tier architecture? So if you got 3 tiers, you got to be going with, well, we know we already have the browser, we have the web server. What else have I talked about today that might add an additional tier on there, an additional level of complexity, a different computer thrown into the mix? So for example, it could be the database. Okay, that might be your 3rd tier. So you have the browser, the server, the web server, and then the database server. That's 3. Okay, 3 different computers, each doing their own specific work. And so that's essentially, and you can have a lot of things besides just a database server. You might have a dedicated computer for handling order fulfillment and payment processing, or another one with a catalog. So the database is all in a big catalog. So essentially this is what's going on. So you have your web client. It makes a number one HTTP request, which goes through the cloud of the internet. That HTTP request gets to the web server. The web server then might have to make find out information from a catalog, pull it back. If you're placing your order, you might also have to go down to the order fulfillment and payment processing computer. So it sends information on there, and then it returns yes or no, as in yes, it worked, or no, it didn't. And then the response heads back to the client. Okay. This is an example of a 3-tier system. Right? All right, so let's move on. So we've been using the Aaarrrgh server throughout the semester now. So what is it made of? Okay, hardware. I have no idea. You know what? I don't really care. I just know that it works. They have purchased a server and they're using it, and I don't know all the details of what it does, what kind of server it is, and how it's working. Okay. What I do, first thing I care about though, is the operating system. Now right now it's currently running on a Windows Server 2008 virtual server, which means it could have multiple instances of the OS running on the same piece of hardware. I don't know if it does. Again, it doesn't matter to me as long as I have enough bandwidth to deliver everything I need for the class. Our web server is Microsoft IIS 7. We do have an email server, although this is not working 100% right now. I'm having the problem is the ECU network does not want SMTP requests sent over it. There's a port that allows you to send that information that has been turned off, so the router does not let those emails be sent out. So guess what? We can't use that unless it's all internal. So and also I believe that like if you're coming from students.ecu.edu, that will not make it to ecu.edu, which is where the Aaarrrgh server is set up on. All right, FTP server. We did set this up so we could transfer files to the server. Now, you're probably using FileZilla client. On the Aaarrrgh server, we have this server version of that software, which receives the files that you're uploading, okay, or delivers files back down as you're downloading. And those files automatically are sent to the correct folder. So the setup there. So we have to have an FTP server there for you to do this file transfer up and down. For server-side scripting, we have PHP version 5.3.6. The database is MySQL version 5.5.15. You're probably wondering, why am I giving you all these version numbers? And I'll explain here in a second. WordPress has been installed on top of the PHP in MySQL. So the website you see is a WordPress website. And I know I haven't talked much about what WordPress is, but essentially it is a content management system that what's really great about it is it makes creating a website quick and easy without knowing a lick of code. Right? And you guys will see this later. That's part of your project. But it's pretty powerful. Okay. All right. We also have MediaWiki installed on top of PHP and MySQL. Right. Again, luckily we already had PHP and MySQL in there, so we created a new database instance for MediaWiki. So that's what we're using there. All right, so some issues with a web server setup. One can be spam. All right. Now, we had an instance with, this can both be email spam and website spam. Now, we had with the MediaWiki, we ran into an instance where we didn't change the default admin login and password. Somebody discovered our website and started to change, because it's a wiki, anybody can change it. They started to come in and change the contents of the website. They started putting up ads for all kinds of things from drugs to male enhancement products. That's basically a form of spam, and it wasn't really called hacking, because I guess you could say it is, because they figured out our admin login and password, but then they spammed the heck out of that wiki site because they could. Okay, so we learned a lesson from that, which is change the default admin login and password. We also learned that you have to control who has access to that site. In some cases, especially for a site with only a few users that only look at it occasionally, you can easily control who gets invitations, who has access to make changes to that website. And sometimes it's very appropriate. Okay. So the other issues you have to deal with web servers: hackers. People who can break into your system. So it's always very important to keep up with system updates. If you go back and look at the version numbers I've listed for PHP and MySQL, well, you always want to try to keep the most recent version installed. That can run into some issues too, but the reason why is because most of the recent version usually takes care of any security holes that might be out there. And hackers usually are aware of the security holes, and they'll systematically look for websites that have not fixed security holes. Now, the ironic thing about this is a lot of the hackers don't even know about a security hole until an update comes out and says, we just fixed a security hole. And what do? They will say, oh, there's a hole here. What can we do with it? Well, okay, now I find out how we can hack into it. Let's see if anybody forgot to do the update. And then they do their search, they find them, and they take advantage of it. Okay. Keeping up to date is very important. Now, the side effect of keeping up to date. Okay, so suppose I want to update PHP. All right. Here. So for example, I'll come back to the DOS attack. You can run into incompatibility between versions. So for example, MediaWiki only works with PHP 5.2.3 or later, except 5.3.1. So when I was doing my research for installing MediaWiki and making sure it's compatible, this is what I discovered. So let's suppose you have 5.2 or .17, and then there's an update to 5.3.1, and you just blindly click on update the PHP, the PHP version. Now suddenly MediaWiki is going to have some problems. Okay. So that is also another issue that you can run into, is that sometimes updates make some of your other code break and not work. Now, 99% of the time, that's not an issue. Maybe not quite 99. Let's say 95% of the time, that's not an issue. The other 5% of the time, it is. Okay. All right. So incompatibility between versions, major issue. All right. And now the other one I was going to talk about is the DOS, which stands for Denial of Service Attack. So if you're managing a web server, this is basically a type of an attack where they bombard your server with requests. So maybe requesting a specific web page. Maybe they're doing what's called a ping attack, where they send a ping is essentially a confirmation that you exist. Okay, so they call it a ping because user returns, and you hear this little ping, letting you know that it's finished its job. This is just a way to take down a website and make it unusable. Okay, a denial of service attack. They're not actually hacking into your site. They're just bombarding. And usually they do this when there's some sort of company or organization that they really don't like. For whatever reason, they decide, hey, let's annoy the heck out of them by trying to make their website unusable. And they do that by sending so many requests, and this might be millions of requests. Just remember back when I talked in the beginning of this lecture about having hardware that can reach a certain benchmark, so it could be able to handle, let's say, 1,000 requests every second. Well, what a denial of service attack will say, if it can handle 1,000 requests every second, we'll send 10,000 requests every second. Now that hardware can't handle it. There's too much, and it starts bogging down the system, and it can't return results to people, legitimate people who want to be able to use it. All right, so those are your major issues with web server setups. Spam, hackers, denial of service attacks, and incompatibility between versions. How do you fix these? We'll get a little bit more into security here in a couple chapters. And so we're not going to dig down into it today. Let's take a look at how can we put these together now. Well, generally speaking, at this point, there's not a whole lot of talk about the hardware that you use, at least not from the web developer's perspective, because usually, like I said, it's more of a systems or network administrator issue to worry about setting up the hardware. As a web developer, what matters to you the most is going to be the software used, starting with the operating system, the web server, the programming language, and perhaps even the database. A common combination, and you might hear this term in the future, is something called the LAMP stack, L-A-M-P. And what does the LAMP stack stand for? Well, L stands for Linux. That's your operating system. A is the web server, Apache. M stands for MySQL database. And P stands for PHP, as in the server-side programming language. Okay, so the LAMP stack is basically, and what's unique about all of these, Linux, Apache, MySQL, and PHP, is that they're all open source, which means they're all free. So when somebody says they're installing the LAMP stack, they're basically saying, on whatever hardware I'm using, I'm going to install this free web solution and then get started creating a website. Okay. Now, there are variations of that LAMP stack, and I've listed two called the WAMP and the WIMP. Instead of L, you have W, which stands for Windows. So your operating system could be Windows with Apache server on MySQL and PHP, or you could have, and this is what we were using, Windows with IIS with MySQL and PHP. Okay. Now, if I'm creating a website in PHP, there's very, very, very little I have to know about the actual web server I'm working with. There is a few idiosyncrasies between Apache and IIS, and we're not going to get into it in this in our class because we're not getting that in depth. Just know that there are a few really minor things that are different between them that a PHP developer would have to know about. Okay. For the most part, though, your programming is going to be exactly the same. Now, there might be some other differences. Actually, your differences get a little bigger if you start changing the database server you're working with or changing the email server you're working with. Again, we're not going to have the time in this class to go into that depth. I'd love to give a much more advanced class in some of that stuff, but we're not going to have time. So at any rate, this is your general software combinations, which you see very often. And then you might even see what might be called the WISA, W-I-S-A, which stands for Windows IIS SQL Server, or Microsoft SQL Server, and then ASP.NET. Okay, that might be an entire Windows-based software combination. That can be a common one as well. All right, so from a business perspective now, what can you do to set this up? All right, and I actually found a pretty clever little video online, and I thought I would share it with you that helps go through the options, gives some good analogies. So let me throw this at you. and then we'll talk a bit more about what they're saying.
Okay, so there are 3 common types of web hosting available to you. The first type is shared web hosting. Shared hosting is like living in an apartment building. Shared hosting is a relatively cheap form of hosting where most websites live. Like an apartment, it often comes with all the necessities, like WordPress hosting, web builders, email clients, etc. But like a real apartment building, the trade-off is that you share the facilities with many other people. What you do in your apartment could affect other tenants or other websites. Like surges in web traffic, parking spaces will be hard to find. Likewise, if you have a lot of parties, you'll probably be talking with building management or the systems group about moving to a different space. The second type of hosting available is virtual private servers. Like a townhome versus an apartment, a VPS is bigger and gives you more control than a shared hosting account. With a VPS, you have control over nearly everything inside your walls, but you share the property with certain services like processor usage. You can now add walls and install whatever furnishings you like. For example, music streaming software for running a radio show, assuming it all fits in your space. So it's much more flexible than shared hosting. The walls are thicker than an apartment, and there are fewer residents on the property. And throwing a bigger party or having lots of web visitors is easier. The last type of hosting is known as dedicated servers. A dedicated server is like owning your own dedicated server. It's basically a box with all the computer bits in a remote rack somewhere. Having a dedicated server is like owning a big house on a hill. The property is completely yours. You can move walls, build a deck, or a pool. In computer terms, that would mean buying as many resource upgrades as you could afford. You can even hold parties as big as you want. Once again, assuming you have the road and parking to handle it. That's like making sure you have the bandwidth from your ISP or internet service provider to cope with your massive amounts of visitors. But be careful, you'll have to stay within the laws, where those dreaded sysadmins will show up again. There you go, and that's what web hosting is all about.
All right, so hope you guys enjoyed that. It's a good way of breaking down the different types of server options. And I do have one difference I would say I would throw into that, which is they describe the dedicated server as owning your own home. I would say almost. It's not just it's owning your own home, the building, but not the ground. So a better analogy might be like a mobile home, where you own the actual physical mobile home, but not the ground that it's put on. And that's a dedicated server, or what I call here a virtual dedicated server. Now, if you really want the true analogy, it would be a do-it-yourself. You own and run your own hardware. You build it, you host everything yourself. You still have to pay for bandwidth, but that would be more analogous to owning your own home and owning the property underneath of it. Okay, the ground. Okay, that would be more like the do-it-yourself option. And they also missed, I think, another type of option that businesses could consider, and some of them do, what I call the virtual website. And I don't know if that's an actual term people have used. I liken this to something like like a Blogger, which is Google's blogging website. Now, a business could decide we don't need something very heavy duty, but a nice simple solution like Blogger or maybe WordPress.com, not the host solution, but the one where you use their servers, where you basically can rent hardware, bandwidth, operating system, web server, and a website creation tool. So you basically have that. You can use their tool to create the website. You don't even have to do any of that work yourself. Okay, you just add the content, pick a design, and bam, there you go. Okay, and that might be like I was thinking like an apartment that comes furnished, right? So there are apartments that are completely furnished versus an unfurnished apartment, which might be either the virtual server that they talked about. or sometimes just called a shared hosting or web hosting. Okay, so I broke it out into 5 different categories, and I think this pretty much covers all the different possibilities you can do, from the do-it-yourself to the dedicated server to the virtual private server, or sometimes called a managed server, to just what's called a virtual server or web hosting or shared hosting, to the virtual website. And each one of these has a different things that you're renting basically from somebody else. Now, from all the way to the virtual private server, you're pretty much renting everything, and you're just adding content and picking a design. The virtual website, you're renting the hardware, bandwidth, operating system, web server. And so for each one of these levels, you're basically doing more work yourself. Now, here's the real ironic thing about this. You would think that the more work that they're hosting and they're doing themselves, the more it'll cost. Actually, you find the inverse of that tends to be true. So a virtual website, many of those are actually free. A virtual server or a shared hosting, there's a lot of them out there who can offer you a website for less than or around $5 a month. Okay. Now you can scale that up, even though it's still a shared hosting. You can, if you're using a lot more bandwidth or whatever, you can pay more and get better capabilities on your website. But that is the base, the entry level. At a virtual private server or managed server, now you're paying a lot more money. Sometimes this will cost you $100 or $200 a month. The dedicated server might be as much as even more than that. And then do it yourself, well, you really don't have to pay anybody else because you're doing everything yourself. But you have to pay for the bandwidth. And oftentimes that bandwidth will easily cost you $1,000 or $2,000 every month. But that bandwidth is dedicated just for you. Now, that being said, generally speaking, as you move up this list from the bottom to the top, you're going from very simple, not very high, not very popular websites to much more control for having much more high quality, much more intensive websites. And that's why the cost, I think, goes up, is because your needs drastically change. All right, let's move on. All right, if I can get this to move, there we go. Now, the last thing I want to talk about were different utility programs, and there's a lot of different things we can talk about. There's a lot of different utilities, so some of the big ones that at least need some mention. Now, there's a couple that you can actually access from what's called the DOS prompt. That's the real old school way of an operating system, the disk operating system. And if you know what the DOS prompt is, you can try using a ping or a trace route. That's the TRACERT is a trace route. A ping essentially will send a message to confirm you can reach a specific IP address. Okay, so it sends a message, and if something returns, your ping was successful, and it'll tell you that. A trace route is a little bit more sophisticated version of the ping. What a trace route does will actually time will give you a time for each bounce on the route to the other IP address you're trying to get to, the other website you're trying to get to. So it will say it took 10 milliseconds to go from your computer to the nearest router, and then it'll say it's gone 20 milliseconds from your computer to the nearest switch, maybe for the university. And then from that switch, it goes to another switch, and from that switch to another switch, and from that switch to a router, and from that router to this computer, and this computer sends you to the web server. So you might have 10 or 15 different machines, different pieces of hardware you actually touch before you get to the web server. And it will tell you the time that it takes to get to each one of those. Now, what this can be really useful for is helping you to discover if or where there are network problems. So if you're trying to get to a web server and it's going really slow and you don't know why, There could be a lot of problems along the way. It could be something on the network. It could be something on their server that's just going slow. You don't know where exactly this problem is. Okay? The TraceWrite will help you identify that. So you can look in between two different IP addresses and say, why is it taking 5 seconds to go from this one piece of hardware to this other one between these two IP addresses? Then what you can do is contact your ISP, your internet service provider, and say, hey, I'm detecting this issue. Can you discover what's going on here? And they may or may not be able to help you. But it gives you much more knowledge to make good decisions about connectivity or bandwidth issues. All right. FTP stands for File Transfer Protocol, right? So FTP is for transferring files locally to the server, especially web pages. It doesn't have to be web pages. You could transfer all kinds of files up there if you wanted to. Telnet generally isn't used much anymore. It's kind of a old school way of running programs on the web server. Okay, it gives you a way of connecting to a server over the internet to tell it to run certain programs. Okay, that's essentially its job. Now, that's been replaced today by things like remote server administration, which I listed last there. For example, I use Microsoft's remote desktop connection to connect from my computer to our web server, which basically brings up the web server's screen, their interface, their Windows interface, so then I can directly interact with it. All right, we can also have data analysis software, also called log files. So every time somebody comes to your website, you can turn on logging, which will basically keep track of their visit. So if the person coming from a certain IP address, the time that they came, but also the time that they go to each of the subsequent pages. So if they click on this page and then go to a different page, you can see the time that they took to go from one page to the other. Now, assuming that the load time was fairly quick, you can estimate how long they spent on a web page. And so log files are very good at doing that and for tracking people as they progress through your website. So you can start identifying patterns on how people navigate your website. Very, very powerful to have that type of information. Okay. You can get further information from log files, such as what type of computer they're using. So if they have a certain operating system, if they have a certain browser, if they're using the screen resolution, that way you know if they're using a large screen, a tablet-sized screen, or a small smartphone screen. And it gives you a better grasp of how many people are looking at my screen at these different sizes, so I can adjust my website accordingly. If suddenly a lot more people are using smaller screens, I can recreate my website to be more adaptable to that. All right, other utility programs include link checking utilities. Especially for a web developer, this is really powerful because it gives you the ability to basically click a button, it'll run through your entire website and look for any broken links. That's awesome, okay? Because you don't want broken links, and if you can easily detect them and find them and fix them, now you got a really sharp website that's going to be much, much nicer. All right. So that's about it for today. We covered basically how can we create the base of our website, right? Where can we put it? Not just, we got a website created, but where does it go? All right. So the web server considerations, you need to look at hardware, software, and utilities, and there's a ton of different options there. Get educated on them. So my advice, learn the most popular configurations first. So like the LAMP stack is a good place to start. Although you may not have to know the operating system as much, so I won't encourage tell you have to go run out and learn how to work with Linux. But knowing how to work with Apache, with MySQL, or with PHP will go a long ways towards your career as a web developer. And also keep in mind that businesses need to consider at what level of service they require and to pay accordingly. Okay. A lot of businesses just getting started out, you can easily go with a cheaper route, but also keep in mind how are you going to move to more complex or more sophisticated services as you need them. Okay, so you need a migration plan of what you can do. So if you start with one level, let's say you start with the virtual dedicated server, I'm sorry, not the virtual dedicated, those shared hosting, how easy would it move from shared hosting into your virtual dedicated server? Okay, so those are the types of things you have to keep in mind. All right. So if you have questions, write those down, and let's bring them to class and we'll talk about them. That's it for Chapter 8, and we'll catch you next time with Chapter 9.